All right, folks, for you guys watching this on video, I forgot to video the first three problems, so after I let this session go, I'll get to the first three problems. So you're going to have to wait for the end of this video to find the first three problems.
Yeah.
I'll say hello to everyone on video.
Hello, video.
There you go. They're very enthusiastic.
I'm gonna listen to myself.
All right, so we'll start with question number 4. All right, so blah, blah, blah. If you want to sell the bond, what dollar price will you receive? There's your price.
Bless you.
There's your price. Okay, so we got the bid and the ask. Okay, and this is a treasury, so we got 106 and 20, 30 seconds, and we have 106 and 15, 30 seconds. And so you want to buy the bond, so the buyer will pay this price, okay? So this is going to be 106% or 1.06 times 1,000, okay? So 1.06 and then 20, 30 seconds. And 20, 30 seconds is 0.625. So we're going to stick that right here. 106.625. Get out of the way. Times 1,000. So we're just going to move this decimal point over 1, 2, and 3. 1066.25. That's what you'll pay. If you want to sell the bond, what dollar price will you receive? Well, the seller will receive the lower price. The dealer gets what's in between. It's the spread. Okay? So that's going to be 106, 1.06, and 15, 30 seconds. Okay? And 15, 30 seconds is 0.468, 46875. Y'all need to do that on your calculator. 15 divided by 32. Should be 0.468. 75. Okay. Times 1,000 equals, so just move this over, 1, 2, and 3, 1064. 0.6875. Okay. All right. I might keep the board cleaned off so we can
So the
stick with the middle of the board. Yep. Go
so
ahead.
the seller will receive 1,064.6785.
The seller gets the lower price. The buyer pays the higher price.
Okay.
Where are you getting that 32 from?
That's the way the market prices work for treasuries. That's the way they work for treasuries. Only for treasuries. All right. What is the fully taxable equivalent yield of the municipal bond? What is the after-tax yield on the corporate bond? So we've got two bonds. A municipal bond has a coupon rate of 5%, 0.05. So this is the muni, which is tax exempt, which means that you don't pay taxes on the interest that you get. The yield is 0.05. So we're going to need the investor tax bracket divided by 1 minus 0.3. The tax bracket is 30%. So 0.05 divided by 0.7 equals 7.142%. And that is the fully taxable equivalent yield. Okay. The corporate bond has a coupon rate of 7%. corporate bond, and it is taxable, is 0.07. What are we going to have after we pay taxes? Times 1 minus 0.3 equals 4.9%. So, if you want to compare a 5% municipal bond to a taxable corporate bond, you have to mark it up. This is a corporate bond would have to yield this or more to have a higher yield than a 5% municipal bond if the investor's in the 30% tax bracket. This is the formula. This is the FTEY, fully taxable equivalent yield. This is the after-tax yield. Okay? Remember, corporate bonds, you have to pay taxes on the interest you receive. Municipal bonds, you do not. That's the deal they pay. They cut. Okay. So that's chapter 7, bonds. There aren't any concept questions on here. Okay. A company paid the following dividends. What will their next dividend likely be? We're going to have to find the growth rate. Multiply the last dividend paid by 1 plus the growth rate. We'll get the next dividend paid. So, in this case, I give you a series of dividends. Therefore, you can compute the CAGR. Okay? So there are 3 ways to get the growth rate: the SGR, the dividend discount model, and the CAGR. And you don't have information to do the SGR or the dividend discount model, but you do have information to get CAGR. So 2.6 divided by 1.5 raised to the 1 over, and we have 1, 2, 3, 4, 5 minus 1, 4 minus 1 is equal to, so 2.6 divided by 1.5 equals yx 4, 1 over x equals minus 1 equals, and what do you get? What's the CAGR?
1.1474.
Yep, 0.1474, okay, plus 1 times $2.60, the last dividend, gives you the next dividend, which is $2.98. See how I did that? D1 equals DO times 1 plus G1. G1 equals CAGR, in this case, equals 0.1474. So last year's dividend times 1 plus the growth rate. And the growth rate's CAGR.
What
Do I
are
see
the other
that?
options for,
There's no other option to
well, like, what are the other ways to do it? It's SGR.
SGR, and then G equals K minus D1 over PO. That's the other way to do it. But so those are the 3 ways. You got CAGR, SGR, and the dividend discount model. That's what this is. This is the dividend discount model. All right. So, like chapters 3 and 4, it's really important to have a really good card for this test. All right, preferred stock pays quarterly dividend of $2.25. Similar preferred stocks have a dividend yield of 9%. what is a fair price to pay for this stock? So, PO of a preferred stock is equal to D1 divided by K. And D1 is 2.25 times 4. 2.25 is a quarterly dividend, and the 9% is an annual yield. So 2.25 times 4 divided by 0.09.
Divide that by
Okay? No, you have to multiply this by 4, or you can divide this by this divided by 4. Either way, same answer. Then you get $9 divided by 0.09 equals $100. So you either multiply this by 4 and divide it by the annual dividend yield, or you take the quarterly dividend and you divide it by the annual yield divided by 4, and you get the same answer either way. All right, a company paid a $2 dividend last year. They expect to grow dividend. What's the fair price to pay? PO. Okay. So they paid PO equals D1 over K minus G. That's all this is. So D1 is $2 times 1.08 divided by 0.10 minus 0.08. So $2 times 1.08 is $2.16 divided by 0.02 equals $108. Everybody see that? Okay, a company has just bought its primary competitor. I'd probably say is considering buying its primary competitor. Either way. Let's clean it off. Company's just bought its primary competitor. They expect to grow dividends 50% the first year, blah, blah, blah. After that, they hope to grow dividends 10% per year. So what kind of growth pattern is this? Super normal to constant. And we've got 1, 2, 3, 4 dividends plus the price. So we'll have 5 cash flows. So we're going to have to find D1, D2, D3, D4, and P4. Okay, so 5 cash flows. The DO is $1.50. Required rate of return is 13%. So we're going to have to find D1, D2, D3, D4, P4 equals D5 divided by K minus G. So D1 is $1.50, 1.5 times 1.5. So that is $2.25. Everybody agree with that? Get your calculators out. D2 equals 2.25 times 1.35, and that is $3.0375. And D3 equals 3.0375. Y'all be sure to make sure you're calculating these. I'm going to post these answers. Okay? I'm going to post the answers, so what you really need to be focused on is going through the calculations, doing the calculations. Okay, 3.0375 times 1.2. And that's $3.64.50. And then D4 is $3.64.50 times 1.15. And that's $4.19, really a little over 19 cents, $4.19. And then D5 is $4.19 times 1.1 divided by K, 0.13, minus the growth rate of 0.10. And so D5 is $4.61 divided by 0.03 equals 153.70. Okay. We found our cash flows. Now we have to find the present value of our cash flows using this discount rate. Divided by 1.13 to the first, divided by 1.13 to the second, divided by 1.13 to the third, divided by 1.13 to the fourth, and divided by 1.13 to the fourth. Show this thing. I can see myself. Hello, hello, hello. Close up. Is it working? Yeah, it's working. You want to see my tonsils? I don't have tonsils. All right. Okay. So, y'all help me with this. Let's see what we got here. I got the answer right here. Let's find the present value. And that would be $1.99 and 2.38. And 2.53 and 2.57 and 94.27. Whoops. Y'all check my math. And so now we're going to add them up. That plus that plus that plus that plus that equals 103.74. And that is a fair price to pay. If we paid this price today, which is the present value of the expected future cash flows, we pay $103.74, and in a year we get 2 1/4. And then in 2 years, we get $3.04. In 3 years, we get $3.65. In 4 years, we get $4.19. And then we also get $153.70. Okay? If all that happens, we will earn 13% per year, each year, for 4 years on that investment. If we want to earn more than 13%, then we have to pay less than that. If we pay more than that, we'll earn less than 13%. If we pay this, and these numbers are larger, we'll earn more than 13%. If we pay this, and these numbers are smaller, we'll earn less than 13%. If we pay this and we get these numbers sooner than we expect, we'll make more than 13%. If we pay this and it takes longer to get these numbers than we expect, we'll earn less than 13%. That's how these things work together. Okay? All right. Everybody see that? So the first thing you do with this is, what is the cash flow pattern? It is non-constant to constant. Okay? So we're going to have to find the present value of expected future cash flows. Non-constant to constant. We're going to have to find each fast-growing dividend, and then in the last year of fast-growing dividends, we'll have to find a price, the terminal value. And the terminal value is K minus G. Here is a growth rate. Okay? It's either K minus G or it's K, or if there's not any more dividends, then there's no terminal value. It's just the present value of the dividends. So you count up the number of years of fast-growing dividends, and we've got 4, plus the terminal value at the end of that period. There are 5 cash flows. We find the 5 cash flows. We divide them by 1 plus the discount rate of 13% raised to the end with whichever period we're going to get them, and add them up. Okay? That's the process. All right? Okay. Let's go to number 10. That's a pretty complicated question. I would say this question, and then maybe a multiple uneven cash flow problem like a deferred annuity. Those two things tend to be the tougher questions for students that work. All right. What is the required rate of return for this stock? So K, and K is equal to cap M. K is equal to D1 over PO plus G, or the dividend yield plus the growth rate. Okay? All right, so what do we have here? Do we have information for a cap M? No, not in question 10. So remember, the cap M is the risk-free rate plus beta times the expected return for the market minus the risk-free rate. And we're not given any of that information, but we are given D1, $1.25, and PO. We're going to use that. Okay, so K is equal to $1.25 divided by 30 plus 0.10. And that is .04167 plus 0.10 equals 14.167%. $1.25 divided by 30. Okay? All right. Wait.
Yeah.
Remember, I'm gonna post it, but go through your calculations. That's the most important thing. All right.
Is that supposed to be times 0.1?
Plus the growth rate. D1 over PO plus G.
Oh, okay.
Yep.
I understand.
All right. Now the next one is also what is K, but it's a cap M problem. All right. What is K? Oh, I'm sorry. It's G. It's a G problem. What's the growth rate? So, do I really have a cap M problem on here? No, I don't. So let's do a cap M problem. K equals what? All right. So let's say the U.S. Treasury has a yield of 2%, and the expected return of the market is 8%, and the stock is 30% more volatile than the market.
What is ERM stand for?
expected return of the market. So K is equal to 0.02 plus 1.3 times 0.08 minus 0.02. So first we do this, 0.06 times 1.3 is, what's that, 1.078? Is that what that is? 1.3 times 0.06?
0.078.
Yeah, plus 0.02. I'm sorry, put 1.078. Plus 0.02 equals 0.098 times 100 equals 9.8%. That's what your K.
What did you say was 30% more volatile than the market?
The stock,
The stock? Okay.
yep, this is beta. What's the beta for the market? 1. Important. Okay. A stock has a required rate of return of 11%. They're trading, the stock's trading at $40. They'll pay a dividend of $2. What is the growth rate of their dividends? So, let's go ahead and get rid of this. Okay, so G is equal to K minus D1 of PO. Okay? So K is 0.11, it was 9.8%. 0.11 minus $2 divided by 40 equals 0.11 minus 0.05. What's $2 divided by 40? That's 5%, right?
That's great.
Equals 0.06 times 100 equals 6%. There's your G. Bless you.
Thank you.
Very dainty. It did not sound like my sneeze. They're gonna have to wash the windows after my sneeze. Y'all have heard?
Reed,
Yeah.
why is it 0.05? Oh, it's
That's the
40.
dividend yield.
Yeah.
Y'all ever heard Jake Stewart sneeze?
Yeah.
When I'm sitting in my office, he's 2 doors down. The wall vibrates like this when he sneezes. It's amazing. I hope he doesn't do that in his sleep at night because he's going to give his wife a heart attack. All right. So now we're going to do a house problem, okay? Because you're going to be facing house decisions, and you're going to be facing car decisions, and you're going to be facing some financial planning decisions, you know, about how to save. Let's do a house problem. So a couple makes $90,000 before taxes. Their average tax rate is 25%. The bank will loan them an amount such that their monthly payment is 27.5% of their after-tax income. The loan terms are 4.5% for 30 years. So the first question is, what will their payment be? So their payment is going to be 27.5% of their after-tax income, and payments are monthly. So let's find their after-tax income. $90,000 times 1 minus the tax rate. So somebody tell me what 90,000 times 1 minus the tax rate is.
67.5 thousand.
67,500. Okay, we're going to divide that by 12. And I think that's 5625, right?
Yes.
Okay. So that's their monthly after-tax income. Monthly after-tax. All right. So their payment is going to be 5625 times 0.275. And that's 1546.88. Everybody see where that came from? How much will the bank loan them? Okay, so 1546.88 plus minus is the payment that they're going to make. So a loan balance is the present value of expected future cash flows. It's the present value of the payments. So we've got 30 years times 12 payments per year, 360 is the in, and 4.5 divided by 12 equals 0.375, and that's the IY. And compute present value. How much is the bank going to loan them?
$305,293
$305,294.
before.
I got it. 0.34.
I got 294. That's what you got, right? Okay. So that's how much the bank will loan them. Okay. How much interest will they pay over the life of the loan? Well, multiply the 1546.88 times 360. And how much do you get? 1546.88 times 360.
156,876.
556 what?
876.
876. Okay? Now let's subtract out the amount we're borrowing, 305, 294, and the difference, 251, 582, 0.8, 583, let's just leave it 583, is the interest. Okay? That's the amount of interest. All right. Now, let's do an amortization table.
So is that like questions?
Those are all different questions that I'll ask you.
Well, we just did like 12 through 18 or 17.
Yeah, now we're going to do 12 through 15. Now we're going to do the amortization table. All right. For 2 months. So the payment number, 1 and 2. And we've got the beginning balance. And we've got the payment amount. And we've got the interest charge. And we got the principal reduction. And we got the ending balance. All right. So what did we say? They're borrowing $305,294, and the payment is 1546.88. All right. And the interest charge is .045 divided by 12 equals .00375, right?
Is that, what's the beginning balance number?
That's the present value of the payments, that's how much the bank is
Oh.
loaning us. All right, so let's multiply the interest, the monthly interest rate, that's the monthly interest rate, times the amount outstanding. And we get 1144.85. That's the amount of interest for the first month. So we subtract the interest from the payment, and we get the principal reduction, $402.03. Then we subtract that principal reduction from the beginning balance, and we get our ending balance, which is $304,891.97. So that becomes our beginning balance here, $304,891.97. And our payment stays the same, $1546.88. And then we multiply the interest rate times the loan balance. And we get our interest charge, $1143.34. Then we subtract the $1143.34 from the payment, and we get $403.54. That's how much principal we're going to reduce in the second month. So then we subtract that principal from the beginning balance, and we get our ending balance of $304,494.43, which happens to be the present value of the remaining 358 payments.
Is that a 494?
Yep,
0.43?
0.43. We made 2 payments. We've got 358 left.
So for the answer for 16, would that be like the second number in the interest column? Because it's how much of the second payment will go to
Yes.
interest?
There's the answer to the interest, and there's the answer to the principal. All right. Let's do a little retirement planning. And this will be on the final too, both of these types of problems, because these are life skills. This is not theory. This is life skills stuff. You're setting up a retirement plan, you're 22. Here we are, we're going to draw, so we're 22, and we want to retire at age 65, and we hope to live for 20 years. Of course, when you're 65, you think you're going to live for 40 years, but then you look at your bank account and you say, I hope I live 5 years. 85. Okay? So, you think you can earn 7%, you'll need $5,000 per month to live on. How much do you have to save each month to retire at age 65? Now, one thing I would tell you is, if I throw in there, you need $8,000 a month to live, and you're going to get $3,000 a month from Social Security, that means from your portfolio, you're going to have to pull $5,000 a month. Keep that in mind. Don't let that confuse you. The key is, how much do you have to pull from your portfolio? Okay? And that will be the total amount you need, less Social Security. All right, so we've got 20 years times 12 payments per year is 240 months. Man, that makes it sound kind of short. I guess 20 years sounds short too. So 240 is our end, and 5,000 is the payment we're going to give to ourselves. And 7 divided by 12 is 0.5833. That's our IY. Compute present value. And we're going to need $644,914.53 Okay? So, now clear your calculator out, and this becomes your future value. Okay? And 65 minus 22 is 43 years times 12, 516, and that is your end. And 7 divided by 12 is 0.5833. That's your IY. Compute payment, and you have $196.85. So if you save $200 a month for the next 43 years, you'll end up with $644,914.53, and you'll be able to pull 240 payments of $5,000 a month from that portfolio before it runs out of cash. What do you ask about?
I keep getting 644, 912.
Somebody else do it.
I got it.
Oh, you got that number? It's probably this. Take 7 divided by 12 equals and put that in as your IY.
Yeah, that's what I've been doing.
Now,
I've got
okay, so put 0.5833 as your IY. Now do it.
down some way further up. 644, 932.
I think that's what I got also.
Payment, 240 is the end, 7 divided by 12 equals the IY. This is how 644,913. Yeah, so there's 912. So yeah, we were off. I was off by $2. So you're going to have to save $196.84 instead of 85 cents.
Just trying to make it save less.
Yep. Okay. We are done. Don't go anywhere, people. Watch the video, because now I'm going to go back and do the first 3 questions. Everyone else, you are free to eat.
Is that the- yeah, it's the page. Or,
Okay, so let's do the first question. How many years until this bond matures? Compute in. That's what we're going to be looking for. All right, so the bond has a current price of $850. $850 plus minus present value. 1,000. Always include that 1,000 future value. Even though it's not listed, you know you're getting that back. Coupon rate of 5%, 0.05 times 1,000 equals $50. Pay semi-annually, divided by 2, 25 is your payment. And market rate of interest is 7%. 7 divided by 2 equals 3.5. That's your IY. Compute in, and you get 21.64 semi-annual periods divided by 2 equals 10.82 years. So that's, and 0.82 times 12, let's see, is 9.8 months. So 10 years and 10 months is how long until this bond matures. All right, let's go to number 2. Bond has a coupon rate of 5%, blah, blah, blah. What is the current market rate or yield to maturity? Compute IY. All right? You're welcome. All right, compute IY. Okay, current price is 900. 900 plus minus present value, 1,000. Just not forget about that, is the future value. Okay? 15 years, you pay semi-annually, times 2, 30 is our end. See y'all, y'all have a good night. Is our end, okay? And let's see, 0.05 times 1,000 is 50, divided by 2 is 25, and that's our payment. Compute IY equals 3.01%. That is a semi-annual IY times 2, 6.02%. Okay? 6.02% is our annual IY, the annual market rate. All right, let's go to question number 3. Okay, what is the fair price to pay for this bond? Compute present value. Okay, so 1,000 is the future value. 0.04 times 1,000 equals 40, divided by 4 equals 10, and that's the interest payment. 7 times 4 equals 28, and that's the end. 3 divided by 4 equals 0.75. That's the IY, that's the market rate. And compute present value, and we get 1062.93. There you go. Okay? Now, notice that the bond is trading at a premium over $1,000, and the reason for that is the coupon rate is 4%, and the market rate is 3%. The market rate has dropped below the coupon rate, which is why the bond is trading at a premium. If the market rate was higher than the coupon rate, the bond would be trading at a discount less than $1,000. All right, I hope that's helpful, and we'll see you in class on Wednesday, and then Wednesday and Thursday are when the times that the exam will be given, days and time. 4 o'clock on Wednesday, and let's see, I don't know. Let's see when the Thursday time is. I got that. Let's get this picture that I took. Thursday, I have in my calendar. Thursday at 5, Wednesday at 4. All right, if you cannot take it either day or time, please email me and let me know. Peace out, shalom, y'all have a good evening. Y'all go practice Spring Sing. Here I am.